Hey guys, welcome back to CMTEQ channel in the series of tutorial on Raspberry Pi and Arduino interfacing. In the previous tutorial, we saw how we were able to build up a bidirectional communications. So that is, we send information from the Raspberry Pi into the Arduino get them and send back a response. So that is assigning a tag into every information that the Pi send. So that is effectively affecting a bidirectional communication. Now, if you are not familiar, if this is the first time you're watching this tutorial, please maybe catch up and familiarize yourself. So we're going to build up from where we left off. Now, in this particular tutorial, we're going to do something more practical that we can see. So that is, we're going to turn on and off, basically controlling this LED here that is attached to the Arduino. So the control will be coming from the Raspberry Pi Python script, and the Arduino will then execute the instructions. So stay tuned until the end of this tutorial so that we can see a fully working Arduino Raspberry Pi control system. So now, without wasting any further time, I'm going to stop this Python script here that is running, and you can see the instructions also just been sent. Arduino also have stopped updating the tag there. Right, so I'm going to come into this Arduino code here. So this is the code that is running into my Arduino, right? So we're going to work here. We're going to first modify this code so that we'll be able to control this particular LED with the serial monitor. Once that is done, we know that this part is working, and then we're going to move on into the script that is then going to control our LEDs from the Raspberry Pi Python script. Again, guys, if you find this tutorial helpful and useful, please give it a thumbs up, and I will also appreciate if you can subscribe to CMTEQ channel. Thank you so very much, so that you don't miss tutorials like this in the near future. All right, so first off, what's the story here? The story here, we need to control this LED. So this is the subject. This LED is a subject here. So we need to know what is a hardware configuration of this LED, right? Now, when we look into our Arduino right here, we can see that the LED is attached to pin 8, 9, 10, 11, 12. So that is pin 12, all right? And then it's going down to the ground pin. So that's our LED configuration. It's on pin 12. So what we're going to do is we're going to first declare an integer here that is now going to hold our LED, right? And we're going to say it's pin 12, okay? Now, after doing that, we can then come into our setup function here. And in our setup function, we're going to declare the pin mode, because we are going to use this LED, right? Pin 12 in what we call as output mode, right? So that is done. Now, this pin 12 default is set up to high. That's why the LED is on. So we need to turn it off, right? So to turn it off, we're going to do just a digital right, and we're going to take that LED, right? And we're going to write a low here, like that, right? So now I'm going to go ahead and just write it in to just make sure that my LED can indeed go off, right? The LED is now off. All right, our LED is now off. That means we are ready to actually start sending the command into the LED to turn it on and off so that we can see it. Now, into the main loop here, we are basically just calling the receive data. So when we go into the receive data, this is a function, right? So we basically just reading the data coming from the serial, which is being sent by the Arduino, and we are executing from there. Now, what we're going to do here is we're going to take the message from the Pi, and we're going to put it into an if statement, right? We're going to say if this message, right, is equal to off, that basically means the LED is going to be off. Or if this message is equal to on, then we're going to turn the LED on. So it basically, we're just going to hard code the instruction that the Raspberry Pi is going to send us via the serial communication. Right, now to do that, I'm going to go ahead and modify this particular code, right? So first of all, we're going to do away with the tag here, because we're not going to be doing the tagging. Now, serial print, let's leave serial print, because we might actually just test our script with a serial print. So what I'm going to do here is, because we already have an advantage of an LCD here, so we can also make use of it. All right, let's go ahead and build our control system here. Now we know that MSG Pi is the variable that is holding the message coming from our Raspberry Pi here. Okay, so what we're going to do here is we need to build the control loop here. So that will be consisting of our if statement. Okay, so I'm going to say if what? If the message, right, that is coming from the Raspberry Pi. Okay, so that is this message here. So I'm gonna say if MSG Pi, right, is equal to what? Is equal to on. Okay, so if it is equal to on, then I'm going to execute this if statement. So now inside the if statement here, I want to copy this message here. So let me just cut it in and paste it there. Auto format. Right, so I'm going to print the message from the Pi into the LCD. So I need to just add a tag here so that we can see that this is coming from the Pi. So I'm gonna say, well, this is what the Pi is saying. Now after getting the command from the Pi, we can then just delay for a few milliseconds. So that will be effectively 300 milliseconds so that we can process the command from the Pi. Now what we're going to do with this command is, okay, since the Pi say we need to turn the LED on, so we're going to call the digital write function again. So digital write, and in the digital write here, we then going to say hi. Okay, so we're going to say hi, but before we can turn hi the LEDs, okay, to turn it on, we also need to display a message. Okay, we also need to display a message on the second line on our LCD. So that will be, I'm going to then copy or cut all of this, right, and I'm going to paste it in here. Auto format again, and here I'm gonna also add another tag. Okay, and then I'm going to say LED, right? So LED with the message that the Pi said, and after writing that, then I'm going to then write hi to the LED that is turning the LED on. Then we move on. Else if the Pi had another control message for us, which is what? Which is if MSG Pi is equal to what? Is equal to off. So if that is the message, we literally just going to repeat everything that we've done there. So I'm going to copy it to save time. Okay, so we're just going to repeat all of this, but this time around we're going to then turn here a low. Okay, so we're going to turn it a low. Now because we're working with the LCD here, so we need to be able to clear the screen of the LCD. So I'm going to call lcd.clear at the start of every command so that we don't see the previous information, so we can only get the current information that the Pi is sending us. So we call lcd clear. Okay, all right, we are actually ready to just to test, but before we do that, I'd like to just copy this line of code and paste it here. Okay, so I'm going to change this to 1. Then I'm gonna write another message here. So command, right? So that will be command, and here it will be wrong, so that we can have the message display on our screen. Wrong command. 1 2 3 4 5 6 7. Okay, because we know that our LCD can only take 8 characters on the row there. Cool. Okay, so now we are actually ready just to test this and see if it's going to work. Now before we do that, let's first write the code in. Okay, the code is being written. Okay, now since we don't have a Python script yet to interface, so we can do the testing with a serial monitor. So I open my serial monitor. As we can see, the LED is off, right? So I'm going to test with the wrong command. So I'm gonna just write test. Okay, and test 0, what does it say? It's a wrong command. So the command sent is wrong. So I'm going to now say on. I want to turn the LED on. I hit on. Nothing is happening, right? So there is also a tag that is assigned to it. So we actually do not need this tag here, so it can be removed. Okay, but we've got a problem here. Maybe it's case sensitive, so let's see. On, capital letters. Okay, Pi say on, where the LED is now on, but it is happening very instantly. Now let's send off. Off. Right, it's happening very instantly. And then test again. It's a wrong command. Okay, so the code is indeed working, but I think I'm going to increase the delay here to just 1000 milliseconds. So that is 1 second, so that we can actually see the time the command have been received to the time that the LED is actually going to turn on. There is a slight delay that we can see. We processing the data and then we are executing them. Okay, so let's open the serial monitor again. Okay, then I'm going to say let's turn on. On, then the LED come on. Let's turn off. Off. Okay, then the LED turn off. Okay, we just need a semicolon there just for the separator. Okay, then we can say test. Wrong command. Okay, so it is working. So we can see that we are able to get data from the serial monitor, right? That is coming serially, and it is executing based on the code that is into our Arduino. Now that part is done. Now we just need to ensure now we can actually send those same command that we're sending via the serial monitor with the Pi. Now to do that, we need to modify this function here that is indeed sending data. Okay, now if we run this function, we're not going to get exactly the same thing anymore, because now we are handling the data we're receiving differently. This function was for the Pi communication. Now we need to write now a function that is going to now send this instruction. A Pi is going to send a on or a off or any other command, and the Arduino will be able to do what is necessary to do with that information. Alright, so if you watched the previous tutorial, you'll know how we came to this Python script here. So we basically have 3 functions in this script. So one of them is just doing the serial connection, okay? And then we got 2 functions that are doing the send data and the receive data. Now we're calling them here. We're only calling the send data here after establishing the serial connection. But inside the send data function, we are also calling the receive data function. Now this is in effect creating that bidirectional communication, because we're sending and receiving at the same time. Now we're going to modify these functions so that we can send the on and off command that we need for the Arduino to turn these LEDs on. Now since we are only sending the command, so we're not going to use the receive data, so we can comment that off. Now that function here, we're sending the data, right? This is the data that we are sending. That is CMTEQ that we're sending, and the Pi is saying, oh, I just sent CMTEQ, right? So I'm just going to basically just modify this function. So since we need to send now a new command, right? So the commands are going to be either on and off. So, and we also need this new character line that we are sending here. So I'm just going to say, well, data is basically equal to data plus, we're going to remove CMTEQ, so that will be just data plus the \n, indicating the end of line. So we're going to a new line. So now those here mean we are sending data, but there is nothing into data here, right? So there is nothing. So if we execute this thing, nothing is going to happen because data is empty. So we need information to place into this data here, and that information, we know it must be the on and off command. All right, so in order for us to get some commands here into our variable data and encode it and send it to the Arduino so that it can execute the LEDs control, so the command that we know we need is on and off. Now, so what I'm going to do here is what we normally do in C programming, where we call the scanf function. So the scanf function will scan whatever user going to enter with the command prompt or with your keyboard, and is going to take the data, assign it into the variable. Now the Python equivalent of that is the input function. So I'm going to create a variable called data, which is this variable here, and I'm going to assign the input function to it so that it can wait for user input from the keyboard, and then take the user input, which will then be the command that will be either on and off, and then send it into our Arduino. But while creating this variable, we're going to ensure that we are actually telling the user what we need to send. So I'm going to just create a variable, call it data, right? And this data is equal to input, right? So this is the input function from Python. So this means here I'm waiting for input data. Now the input data that I'm going to enter is then going to be assigned to this variable data, right? And after that, I'm going to take the data and add a new line character to it, and then send it to the Arduino so that we can get something going, our control system. So here inside the input here, I'm actually telling the user on the command line what you need to do. So I'm going to say, well, select. So you need to select on or off. So that is what the user need to select. So you need to select either on or off. So after you select either on and off, it's then going to be assigned to the data, and then the data will then take and assign a character and send it to the Arduino. Right now, remember, we just comment out the receive data, so which means we don't need to receive anything right now. The Arduino code as is, right? Let me just make sure we just write this again, because we did modify it, put a semicolon there. So let's just write it in. Okay, it's in. So right now in the Arduino code, we've got a serial print line here right at the end, but we are not interested on what is being printed. It's basically what the Pi is sending, and we are printing it again. We are able to receive it with the receive data, as you saw in the previous tutorial on the bidirectional, but we comment it out, so we're not interested in that. We only interested in sending the command so that the Arduino can do what we need it to do. So if this code is good for us, let's just try to run it, okay, and see if we can actually get something going here. Okay, Arduino connected. Okay, so now select on or off. Okay, so I'm going to first check by sending, because remember, whatever I'm writing here is going to be assigned to the variable data, and we are sending a new character, end of character line there, and we're sending it with an encode UTF-8 to the Arduino, and the Arduino will receive it. So I'm going to write test, which supposed to be a wrong command, and then I'll hit enter. So we can see that we just sent test, right, which is the wrong command here for us, so we cannot execute our LED control because test is not recognized. So now let's try by sending on. So Pi is sending on. Okay, so the LED is on, so it is actually working. Now let's try by sending off so that we can turn the LED. Pi say off. Well, Arduino LED is off. Okay, so it is working. So you can put in any other information, it will still say going to be a wrong command. Now let me see if it's also case sensitive on this side here. Okay, it is case sensitive. Case sensitive, so you have to make sure that it is in capital letter as we've done it there. Otherwise, if we change it here to be small letters, then it can also take small letter, or we need to encode it so that everything that it's going to receive, we can write it in capital. So there is a way to do that. So we capitalize every serial information we're receiving. So in that case, whether you write it in capital letter or in small letter, it can still execute the command. So let's write off, then it is off. So this is basically how you can control your Arduino with your Raspberry Pi. So this is really a simple control system. And remember, this is just an LED that we are turning on and off here. Now this could be anything, right? Once you are able to control, toggle a pin, you can literally set anything there. You can put on a relay there that can start an engine. Literally anything can be controlled with this script that we just done here. and you can control a robot, you can control a camera position and all sorts of things just with this script by trying to develop it and work it and make it do exactly what you want it to do. So this is it, guys, for this tutorial. I hope you find anything useful in this tutorial. If it was indeed, please give it a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. Until next time, stay tuned for more tutorial like this in the near future. Cheers.